Good morning, calculus. I totally forgot to make this video last night, but here I am this morning, describing the second page of your homework that I assigned to you on Monday. Y'all, I think this is the first video I've made you as well, so you haven't seen my super high-tech setup, which is I've taken a picture and I'm drawing on paint. Don't you wish you had me during the pandemic year? Okay, so what we did here is I gave you the graph of f prime. So this is the graph of the first derivative of a function. We are going to suss out the second derivative of the function, just kind of by guessing the slopes of the first one. Then we're going to come over here and sketch the curve, the actual function. All right, let's do it. I'm going to use a bunch of different colors. If you're colorblind, you should tell me, because I do use colors a lot. I'll try to use the color and the actual description as well. But yeah, tell me if this is not a good system for you. Okay, for increasing, all of these questions over here are about f, right? I'm asking where f is increasing, where f is concave down, where f has extrema, etc., right? I'm going to answer these questions by changing them into where f is increasing. I'm actually looking at where is f prime positive, where is f prime negative, where is f double prime positive, or where is f double prime negative, right? So I'm going to change these where is f increasing questions to looking at, oh, let's just look at the graph of f prime and see where it's above the x-axis, right? Instead of asking where is f concave down, I'm going to say, no, let's look at the graph of the second derivative and see where it's below the x-axis, right? These are easier things to look at. So now we got to do that. Okay, f prime, where is it positive? It's positive from here to here. It's 0 at 2. It's positive from here to here. It's 0 at 6. So over 0, 1, not 2. I just explicitly said not 2. Over 3, 4, and 5 is a positive function. It's a negative function between 6 and 9. And at 9, it's also 0. So here and here, it's negative. And then I'll make my zeros yellow, actually. See exactly where that's going down. Okay, so far what I've done, I haven't looked at the slope of anything, I haven't looked at the concavity of anything. I've simply looked at the value of f prime, right? How far above or below the x-axis it is. And I've noticed when f prime is positive and when f prime is negative. Nice. Now we're going to label our extrema. Extrema are the maxes and mins. This extrema is neither. F prime, from the left to the right of x equals 2, is positive and then switches to positive again. So this on the function will look like this. It's increasing, it flattens out, and then it increases again afterwards. So this is neither a max or a min. At 6, the actual function is increasing, flattens out, and then decreases. So this is a max. There's a max at x equals 6. And then at 9, our actual function looks like it's decreasing and then stops. Right, so this is like, we're going to call it a min, because it is one. Right, but it's not this classic smaller on both sides minimum. All right. Let's move to the second derivative. First, we need to draw it. So first we need to say, let's estimate when we're drawing, and I want orange, I want this one. When drawing, let's say sketching, because that's what they actually want me to say. When sketching f double prime, we're just notating the slopes of f prime, right? We're plotting the slopes of f prime of the first derivative. So you're taking the derivative of the first derivative to get to the second derivative, and taking the derivative when sketching is just looking at the slopes. All right, so here the slope is negative, the slope is negative, the slope is 0, the slope is positive, the slope is 0, the slope is negative, the slope is negative, the slope is 0, and the slope is positive. So what I did is I drew little tangent lines at each of the x equals integers, and then I just noticed, like, is this a negative slope? Is this a flat slope, so 0, or is this a positive slope? Right. At 0 it was negative, I'm going to put a negative number. At 1 it was slightly less negative, so I'll put a negative number. At 2 it was 0, I'll put a 0. At 3 it was positive. At 4 it was 0. At 5 it was negative. At 6 it was negative. 7 was also negative, I just skipped that for some reason. 8 was 0. 9 was positive. And I'm gonna connect this in kind of a nice way. I'm not gonna make any cusps. We shouldn't expect any cusps. Nothing's wacky in the first derivative. So we're just gonna connect all of these plotted slope points from f prime in our f double prime graph. Okay, now let's see where it's positive and negative. So orange is my positive. F double prime is positive when it's above the x-axis. So it's 0 here, but all of these are positive. It's 0 here. It's 0 here, but all of these are positive. And then where it's negative is where it's below the x-axis. This is below the x-axis. All of this is below the x-axis. Right, so let's put this on our little sign chart. 0 and 1 were negative. That's 1, 2, 3, 4, 5, 6, 7, and 8 are negative. Right, we've still got 2, 5, and 9 being 0. That's not true. Well, let me just actually write in these. 1, 2, 3, 4, 5, 6, 7, 8. That's where I'm messing up. 9. 8 should be 8 and 4. Nice. Ooh, that's not an easy thing to erase, so let's just go back. There we go. Okay. Now we got there. 2 is negative, 4 is negative, 8 is negative, 9 is positive, 3 is positive. Hopefully that didn't mess y'all up too much. Okay. Wow, labeling things really works. Okay, so we've seen now where our first derivative is positive and negative. We've looked at the slopes for the first derivative to make the second derivative sketch. And then we've seen where the second derivative is positive and negative. And now we can come over here to our F questions and answer them, right? F is increasing from 0 to 2 and from 2 to 6. This is easy to say, oh, it's 3, 4, and 5, right? 2 and 6 aren't included. 2.5 is included though, right? 2.1 is, 5.99 is. So we want to say all of these numbers are positive. Or in another way, these numbers are positive. These numbers are positive. There's a hole exactly at 2. Right? These numbers in between are negative. So everything from 6 to 9, but not including 6 and 9. For concave up, where is it orange? It's orange between 2 and 3 and after 8. So between 2 and 3 and after 8. And then where is it concave down? Where is the second derivative negative? We've got from 0 to 2, and then also from 4 to 8, again, between 4 and 8. And then the points of inflection are where it changes sign. So when it goes from negative to positive, green to orange, it changes from green to orange at 2, it changes from orange to green at 4, and it changes from green to orange at 8. Let's graph. Let me move this down so I can make the graph bigger. All of this. Whoop. Then I'm just going to draw my own. One, two, three, 4, 5, 6, 7. 8, 9. Nice. Pretty good. All right. When we're graphing f, put it in red. F. This is the actual function, right? Here's what I'm gonna do. I'm gonna put my maxes and mins in first. I know that I've got a max at 6, and I'm actually gonna 1, 2, 3, 4. This one's 5. I've got a maximum at 6, so I'm just gonna put something kind of up. It doesn't really matter for now how far up we go. I'm gonna put a minimum kind of at 9. I'm gonna say the function's getting smaller. It's there. Right off the bat, it's increasing. So I know at 0, I'm gonna start kind of low, because I'm going to increase all the way until this maximum at x equals 6. Okay, I've plotted my extrema. That was first. Now second, I'm going to dotted line. This is a personal preference, but I recommend it. Dotted line where it's increasing and where it's decreasing. And at 2, I'm going to make a note. It's not actually increasing here. It should be flat. Okay, so this is like the step 1, super basic. I know where it's increasing, I know where it's decreasing, and I know where it's flat. It's flat here. It's flat here. Oh, it's real. And it's flat at x equals 2. Okay, so I plotted points, and I did my endpoints. And then here I crudely hashed in increases, decreases, and flat slopes. No, don't want to say it again. Okay. Nice. Third step is I'm going to plot in points of inflection. I usually do this with an x. Again, this is a personal preference. So points of inflection, there's one at x equals 2. So on my crudely drawn graph, I'm going to put a point of inflection there. There's one at x equals 4 right here. So wherever my y value, quote unquote y value was for this increased hash line, I'm going to put one here. And then there's one at 8. So there's one right here as well. Okay, so I've put in x's on my basic structure where I think that there's going to be points of inflection. Now I'm going to draw on my concave up stuff. This is step 4. Between 2 and 3, it's got to be 2 and 4. Yeah, this should have been 2 and 4, y'all. Between 2 and 4, so between these 2 points of inflection, and after 8, so after this point of inflection, it should be concave up. Concave up is a smiley face. Straight up. So I want to connect these 2 points with a smile. Taking a lot of care to make sure it's flat around this x equals 2 point of inflection. And then it also needs to be a smile from 8 to 9. But it doesn't need to be flat on any of these, I don't think. Oh no, it does need to be flat. I'm so sorry. It needs to be flat around 9. So we'll make sure it looks flat around 9. Alright, fifth, I do my concave down. This should be frowns. It should be a frown between 0 and 2, so I'll start at 2. Start at 0 and end at 2, making sure that it's flat again. It should be a frown between 4 and 8, so between these 2 points of inflection, making sure it's flat at the top here. And now we've got our function. I'm going to now keep saving it because it's an instinct, I'm sorry. Now I'm going to graph it in, I'll do this maroon. Right, so I start at 0, flat, changes to a frown, flat, changes to a smile, flat. Et voila, a function. Right? So again, the plan is we look at the first derivatives, literally just is it above or below the x-axis to make this graph. Then we look at the slopes of the first derivative to sketch this graph. And then we notate whether it's positive or negative. We look at our features of our function. So our features of our function are, is it increasing, decreasing, is it concave up, concave down, where are the points of inflection, where's the max and min? And we change those questions. Instead of saying, I wonder where f is increasing, I say, I know where f prime is positive. Instead of struggling to kind of figure out what does concave up in the function look like on the first derivative graph, we can instead say, where's the second derivative positive? Right? Once we translate all of our questions into things we know, we can figure out where it's increasing and decreasing. We can sketch that. We can figure out where it's got maxes and mins. We can sketch that. We can draw in the concavity by saying those starts and stop points with the points of inflection. Cool. And then the other big thing is, here's the equivalent statements, right? So when I ask you, is f prime increasing? The thing you can change that sentence to is f double prime positive? And all of these mean the same thing as is f concave up. So if I ask you any of these three, you can instead answer your favorite of these three, right? If I ask you, is f concave up, and I give you a graph of f, we probably do want to look at this. But if I ask you, is f concave up, and I give you a graph of f prime, either we should answer this question, or we should make the second derivative graph and answer this question. Like this. And then the other is if f prime is positive, then f is increasing. Right? And if you, oh my gosh, the save is really an instinct. And if you say, okay, what about decreasing? Then it's negative, then it's concave down. Right? Okay, I'll post these notes and I'll post this video to the Google Classroom. I'd recommend watching this in the next couple days, redoing your homework maybe with me on the video. Let me know if the class is going too fast and you want me to kind of post these extra videos so that you can sit with them and think about it. Yeah. Go team. I'll see y'all in 6th.